So welcome back. I am here, Dr. Manil Verma, and this topic that basic components of system input file, and that input file is in actually this FDF, and this FDF actually stands for flexible flexible data file. And in this lecture, I will discuss about the short glimpse of this sister tool, and then this FDF file, the components of this FDF file, and some basic components which is uh, required to put in that FDF file we will discuss. So let's begin. So first of all, I should show you that web page of Sista. This is that Sista home page, and here one line statement is given. So as far as the Sista is concerned, Sista is both the method and computer program to implementation to perform efficient electronic structure calculation as well as ab initio molecular modeling simulation of these molecules as well as solids. And its efficient systems from the use of basis set in the strictly localized atomic orbitals, and also this it is a balanced tool for the accuracy as well as computational cost. Simulation matching the quality of other approaches like plane wave based methods. So this is that this wave page where all the characteristics and the capabilities of this system is mentioned here. And what is this system? It's given, getting the code, how you can get this code, how to install that. And now the recent version is this. So this is that recent version, although generally I prefer that 4.1.5 so far. And that documentation part is also very rich, but the contents of that older one, for example, let me open this. So yes, so that lectures, video lectures and other things are mentioned. So this is well documented web page. After successful installation of this system, you will get this type of folders in that system page, system package. This is subject directory where it is compiled, and then this test directory. There are so many examples are given to help you, and these are that post processing utilities to help you for the calculation. These three folders are very important: that test and these utils and that objective directories. So that installation process and other things I have mentioned in some other lecture. So you can go there and check that how we can uh, install this in series as well as in parallel. So let me open any input file. So for okay, so let us discuss about that component of this input file. So the first one is that is the default component, that is one can give by using their own method. So this input file is for gallium oxide. So this is gallium oxide. This is the number of atoms. So how many numbers of atoms we are taking. So this number of atoms, so one can count from here, that is 1, 2, 3 and 4. And number of species. So this is two species system. One is gallium and second one is oxygen. So these are two species system. So these are that which, and this is that lattice parameters. So since it is hexagonal structure, so hexagonal structure material, so it's this is the value of A, this is B, and this is C, and that is alpha, beta and gamma. So gamma is 120, one can observe here. So this is that the basic information related to that structure. The next is for that calculation accuracy. This is that k points, and this is concerned with that reciprocal lattice system. So for optimize, during optimization process, we optimize these k points, and then the next part is this basis size. That basis size, this is also for use calculation, and we also optimize this basis size. So what is that basis size? I will include in one more talk in the detail. And then this is that mesh cutoff. So this related to the calculation in the real space. So this is mesh cutoff, and we also optimize these parameters. So during that optimization, or that is known as convergence test, we use this mesh cutoff optimization, and this is optimized one, and this is exchange correlation function, and this is also optimized one. So during this optimization we use this, and these are that four parameters, and during that power cut and other technical issues, if that program is stopped, then by using these files created by these 4 lines, can reuse that older files and that restart that program at the same point where it is stopped. So that optimization parameters are this, and we also optimize this lattice constant. So we also optimize this. So these are that basic components of an input file, and this template I generally use because if we want to use that files generated by ZDIS, for example, I have generated that input files by using GDIS many times. For example, let me check this. So here, this is that input file generated by this. So many default parameters it is listed. So, and all these parameters are not used at a single time. If we want to create that FDF file, then we generally want these two main parameters. One is these lattice parameters, and second one is the in coordinate. In other parameters, we can take the help of our basic knowledge and create that. But these coordinates of these atoms, these are that 4 coordinates of this atom. This is very important, and by using that different designing tool, we generally adopt coordinates from that tool. So, anyways, so hope you will now able to design this FDF file, that input file. Thank you all.